So we've talked a little bit about what energy is and where it's used. And now we're going to talk about where does that energy come from? What type of fuel is going to be used? We're also going to talk about the chemical reaction of fossil fuels because that particular chemical reaction, and come on, it's chemistry class. We have to look at the reaction. So this slide gives a breakdown of some of the different um, sources where we get our energy. It turns out most of our energy are from fossil fuels. We also have nuclear and renewable. Now, fossil fuels, actually slightly into nuclear depending on who you talk about, these are considered to be non-renewable. Non-renewable. That doesn't look really like non-renewable, but I think you know what I'm talking about here. Non-renewable means that it's being used at a much faster rate than which is being replaced. So where did the fossil fuels come from? Well, I always joke and say that they came from the dinosaur. They actually came from decaying plant and animal material. So yeah, dinosaurs are in there along with a lot of plant life. They get stuck in the bogs, they start breaking down, and then they're slowly converted to these hydrocarbons that we can then use for other things. So hydrocarbons, if you remember that from the first chapter, I think, not first chapter, second chapter, third chapter, one of those chapters, we talked about what a hydrocarbon is. A hydrocarbon just means that you have carbon and you have hydrogen, just those two elements in some sort of a compound. And that chain of carbons can be different lengths, as we're going to find out. So some examples of fossil fuels include natural gas. Now I've got some notes written over here, so I'm going to put my glasses on to read them better. So your natural gas, the most common form of that is just CH4. That's methane. There are some impurities that get involved with natural gas. It's considered to be the cleanest burning fossil fuel that we have. And about half of the homes in the US are heated with natural gas. If you live out in the country, you probably use propane, but if you're in the city, you have a natural gas line. Now, natural gas itself is odorless. You cannot smell it. Well, that's a concern in case there was a leak. So if you have natural gas going to your house, they add another component called mercaptan. And mercaptan has a really, really bad sulfur smell. So in case there was a leak, you would smell that and hopefully not cause an explosion and, make your house blow up or anything. So yeah, that's why they add that mercaptan. So methane itself does not smell. Petroleum is next. Petroleum comes from our crude oil. We're going to have some more information about that here in a bit. And then we have coal. Coal is the most plentiful, so we have lots and lots of coal in this country. It's the cheapest, it's the least expensive, but it also has the most pollution. And the reason that we have lots of pollution with that is just that there are different components, different compounds that are in the coal as they extract it from the earth. So then we can talk about, are you supposed to try to remove that or not? So it gets to be a little bit I don't know, controversial. Now, another controversial area is actually within that methane gas, that natural gas. So right now we use something called fracking to release that natural gas. If you're from the Midwest, especially that Oklahoma-Kansas line, you've probably heard something about fracking. And what they do with fracking is they inject a high pressure solution of water, sand, and chemical additives deep underground, and it causes it to fracture rock formations and release this natural gas, which we then collect, and then we try to use it for heating our homes or whatever the case might be. They're trying to firmly establish whether or not there's a relationship between this fracking in the oil industry and then all the earthquakes that have actually been occurring in the Midwest. So in case you hear about that, that gives you just a little bit more information about that. Now, keeping going on here, let's see here, we have nuclear. Nuclear is going to use a radioactive substance. We actually have some chapters about this later on that you'll get to learn about. And then we have renewable resources. So renewable resources would be like wind power. So I'm from Kansas, go out west, you'll see all the great big wind turbines, the wind farms. We could talk about solar energy. So, you see it more and more. People will have solar panels on their house. And the last one that they'll often talk about in this area, or one of the other ones we haven't even talked about, like hydropower. But another one they'll talk about is a biofuel, and that's where we use byproducts in the agricultural field to be able to burn. So ethanol, they're looking at using like sugar canes and different things like that, and be able to use that to get the energy to heat our homes or transport things or whatever the case might be. If you look at the pie chart, you'll see that nearly 84% of the energy that's used by the U.S. comes from fossil fuels. So our oil, our coal, and our natural gas. And out of those, most of it is actually from petroleum, from oil. As of right now, there is a push to try to make it more environmentally friendly, but you have to balance that environmentally friendly and cost. And sometimes what they say is more environmentally friendly, they kind of greenwash stuff. It's not as friendly as what you would like it to be. Now, worldwide, we had been the highest energy consumer. We're not anymore. China has actually uses more energy than the U.S. at this point. However, if you look at per capita, because we use so much energy per person, we still win in that category. So we use the most energy per capita in the world. I don't think that's really something to be proud of, but hey, it's there. And this is kind of a fun little fact. So the U.S., as we had learned on a previous slide, uses about 20% of worldwide energy use. So about 20% of all the energy used in the world is due to us here in the U.S. How much population do we have compared to everyone else? We only have 5% of the world's population, but 20% of the energy use. It's kind of a sad fact there. So let's look at the actual reaction of what's going to happen whenever we have a combustion of a fossil fuel, meaning that we're going to burn a fossil fuel. You're going to burn petroleum, you're going to burn some coal, whatever the case might be. Well, we're going to have the reaction of the fuel, and if you burn something, you have to have oxygen available. And whenever you burn that fuel, it's going to produce heat and light. And we're concerned about the heat. There are some other byproducts that are going to be produced, as we're going to see. Now, this particular reaction is considered to be exothermic. Exothermic, that just means that heat is released. The opposite of exothermic is endothermic. Endothermic. And endothermic means that heat is absorbed. Heat absorbed. So the most common endothermic reaction you may have seen, if you've ever played sports and they had the cold packs where you hit it and it instantly starts to get cold, that's endothermic. It's absorbing energy. So it's absorbing energy from the surroundings, and that's why it feels like it's cold on your hands. Exothermic means that heat is released, so the temperature goes up. And this is an example of something of what we call oxidation. Oxidation means that there's a transfer of electrons, and you'll actually get to see oxidation reactions later on in an entire chapter. So down at the bottom, I have a balanced equation describing what is occurring as we combust a fossil fuel. So we start with our hydrocarbon, that's this thing right here. Now this one happens to be methane. Methane reacts with oxygen. Oh, notice this little 2 down here. What does that 2 mean? That subscript. Remember, that means that it's a diatomic molecule. So there's when it's in its standard state, oxygen likes to be diatomic. So methane reacts with oxygen and it produces or yields, that's what that arrow means, these products. Woo, there we go. So the products include carbon dioxide, we have water. Now think about that. When you burn something, you produce water. And then heat. And the heat on the product side means that it's exothermic. So your hydrocarbon, in this case methane, and two oxygens react to make a carbon dioxide and two waters and heat. Again, that's a balanced chemical equation at the bottom. We'll talk more about balanced chemical equations later on. Little fun fact for you, for every gallon of gasoline that's burned, about 20 pounds of carbon dioxide are released into the atmosphere. All right, so your little question for this section says carbohydrates are the main source of molecules in petroleum fuel. True or false? Carbohydrates are the main source of molecules in petroleum fuel. Answer? That should be false. So carbohydrates you've heard of it regarding foods, and we'll talk about it in the foods section. But for your petroleum fuel, your main source of molecules are hydrocarbons. Carbon plus hydrogen. A carbohydrate has some oxygen involved in it, and it's a slightly different compound. So false.